All right, in this section, we're looking at 2.8, the function operations and composition. And we've actually talked about this a little bit in some of the previous sections. We've talked about how we can add, subtract, multiply, and divide two different functions. But this is the official section where that shows up in. So what we're looking at, first of all, if you have two functions, say a function f and a function g, and you want to add those two functions together, we can do that. For example, let's say we have a function f of x equals 5x minus 7, and then a function g of x equals this. It just says to add the two of them together. You're just going to combine the like terms. So you would say 5x minus 7 plus 2x squared plus 3. Combine any like terms. The x squared term we could put in the front, then the x term, and then minus 7 and 3 could be combined to be minus 4. And that would be just f plus g, the two functions added together. As long as there's just an x there, we can't work it all the way out. We don't have a number to put in, so that is the answer. Then we can subtract functions, function f minus function g, or think of it that way as well. So that's number 2, f minus g of x. So function f, it says, is 5x minus 7. That function minus function g, 2x squared plus 3. This time, because it's subtract, we will need to distribute the negative, so you do need to watch out for that on the subtraction ones. It subtracts the entire rest of the second function, so it distributes the negative. In order, the x squared term, then the 5x, and minus 7 and minus 3 makes minus 10, and that's all we can do to that. Now, if it said f minus g at 1 and it put a number there, we would plug the 1 in for the x's, and we could work it out further. But that's all we can do if an x is just there. F times g at x means times function f times function g. Okay, so that will look like function f, 5x minus 7, times function g. All right, go ahead, always pause the video and give yourself some time to think about that. But that is multiplication. If it says fg of x, that means multiply. The little multiply is understood. Or if it has an x between it. Usually, though, we don't put the x there because that's just can be confusing with the algebra x. So just nothing or a little dot, that means times. But anyway, that means the FOIL method. In this example, we'll need to FOIL. The first times the first makes 10. X to the third. We don't do that much. X to the first times x to the second makes x to the third, though. Outer will be 15x to the first. Inner minus 14x squared, and then last times last is minus 21. And actually none of those are like terms, so just maybe rearrange it so it's in descending order of the variable. It would look like that. Again, if there's no number to fill in, that's just leaving it in terms of x. Number 4, we're going to divide f divided by g of x. So that means function f, the 5x minus 7, divided by function g. So think about that for a minute. Is there any algebra you know to do to that, to clean that up or rearrange it? And if so, we should do that. Always simplify fractions if possible. But actually, that's all you can do there. So that would be your answer. There's no better form of that. Okay, then number 5 on your handout, f times g, or fg at 2. So if there's a number here, that means plug that in for x. Now, you can do it individually, do f of 2 times g of 2. Or you can take function f times function g and then plug in the 2. I'm going to demonstrate both ways. You get exactly the same answer. We actually did that already in step 3 or number 3, and we have this 10x cubed minus 14x squared plus 15x minus 21. So we could plug in the 2 for that. And that's a little more work. I think it'd be easier to do f of 2 times g of 2, do them individually. See, f of 2 would mean 5x minus 7 with a 2 plugged in. That's 5 times 2, 10. 10 minus 7, that's 3. And then g of 2, that was 2x squared. So plugging in a 2, looks like that. That would be 4 times 2, 8, plus 3, 11. 3, then you get your answer for that. We found that to be 3. Get your answer for that. We found that to be 11. Then 3 times 11, 33. So you can do it individually. It's kind of better if you have a number there. We have arithmetic on our side. We can do it with arithmetic. Whereas if it's just in terms of x, we just have the algebra. We leave it in the algebra form. Also notice if I crunch this through my calculator, that should also give me the exact same answer, 33. So either method is fine. And that's true for all of those examples. If there's a number in it, you could do it individually, or you can do the algebra first and then plug in the number. Number 6, given the function below, find f of 1 and then find f of negative 3. So you should have a picture on your handout. And it's not necessarily one of our 10 basic functions or something we're supposed to recognize, but it's some sort of graph with some values listed, but it's also got other values. But to help us out, they've kind of highlighted some of the points, their turning points. So to find f of 1 means when x is 1, what is y? Find the y value at x is 1. Really, that's what we were doing in all these above, too. If you have an equation, for example, here, if I were finding f of 1, and I'm given an f of x equation, that means plug 1 in for x. 5 times 1, 5, minus 7, negative 2. So that's what it means. Plug that in for x, see what y is, or the answer when you work it out. So it's the same thing here, except we have a picture. So that means go to x is 1. So where is x is 1, right? Look at the x-axis. Over here is x is 1. And then see what y value the graph hits it at. So it looks like 2. Do you see that? It goes up 2 places. At x is 1, y is 2. Okay, you all try it on the next one. Go to x is negative 3 and figure out that answer. So at negative 3, we go back 3, and it is down 4 places. So the y value at x is negative 3 is negative 4. And that's how you do it when you have a picture. The next page is the narrative about what a composite function means. A composite function is a function within a function. So the little open circle, let's see, can you see this? The little open circle tells us that we're doing a composite or a composition. It's a function within a function. You put the second function inside the first function. So sometimes it's written like this, sort of looks like the word fog, but we say f of g of x, and it means the same thing as writing it like this, plugging function g inside of a function f. So, for example, if we have f of x equals 3x plus 5, we know to find like f of 0, just to kind of review on that, f of 0 means plug 0 in for x and do 3 times 0 plus 5, which is 5. We can do f of 2, plug in 2 for x, that's 3 times 2 plus 5, or 11. F of negative 3 means plug negative 3 in for x. So again, that just means plug that in for the x value. So what is the pattern? You take whatever is in that parenthesis, or whatever, they've got for the x there, and plug it into the function. So what if you had a g of x that equals 2x minus 1, and it said plug function g into function x, or f. That means take the whole function and plug it into the x value. So if we had f of g of x in that notation, I think it makes it a little more sense to see it like that. That means plug g of x into function f. Just like we were doing here. Whatever you see in the parenthesis, that's what you plug into the x value. And if there would be more than one x value, you plug it in for all the x's and then work it out. So if we're supposed to plug in function g, the whole function g, so that looks like 3 instead of x, function g, 2x minus 1 plus 5. And then we do a little algebra, distribute that, and combine any like terms. And that would be our answer for f of g of x. Again, sometimes it's written like this, but also the little open circle means that. It means the second function plugged into the first function. You can also do that in reverse. We could do g of f of x. All right, at the top of the next page, you can see it's got the steps there, the 6x plus 2. But what I'd like you to try now is do g of f of x. Do it the other direction for the same functions. F of x is 3x plus 5, and g of x being 2x minus 1. I'm going to do GOF this time, function f into function g. So we'll go this direction, plugged into the x over here. It'll be 2 parentheses, plug in function f, and then distribute and combine any like terms. So 6x plus 9 when you go the other direction. All right, so please do the you try now. Again, pause the video, take a minute, try these two new defined f of x, g of x, do fog and golf in those, please. Okay, so I'm going to go ahead. Fog would mean take function g, plug it into the x value here. Let me write that on this paper. So that would look like 5. Instead of x, we type in 2x squared plus 3. Distribute. Combine any like terms. Okay, that's the first part. That would be the fog, f of g of x. Now going the other direction, GOF, we're going to do the other way, function f plugged into the x value and function g. So here we'll have the 2, and instead of x, 5x minus 7 squared plus 3. Now to work this out, we've got to be careful. This binomial squared sometimes gives us trouble. We have to square that first before you can distribute the 2. Do you remember that from order of operation? Squaring or exponents are always done before timesing. So to square 5x minus 7, you could write that down twice and then FOIL it. Or if you kind of know the squaring pattern, it's always the square of the first, that's the 25x squared. You do have the square of the last, the 49, but you also have the outer is negative 35x, and the inner another negative 35x, making negative 70x. Do you remember that? The squaring pattern, we've kind of been talking about that now for a little while. It comes up every now and then, and it's handy if you kind of remember that pattern. Anytime you have a binomial squared, you square the first, you do square the last, sort of like you would think about the squaring, but you also have, and it's because of the FOIL method, the outer and inner are the same value, negative 35x doubled, making that negative 70x. Now we can distribute the 2 and add the 3, and that will be 50x squared minus 140x plus 98 plus 3 for a final answer of 101 on the end. And that's how it would look if it just has an X to fill in. Now remember, if there's a number there, it's actually much easier. Let's look at one with a number in it. Let's say we were doing f of g of 1, for example. So we could take what we just found for f of g, we could do it from this form and plug in the 1 and get 1 squared is 1 times 10, or just use your calculator, you get 18. But what I think is much easier, we have the luxury when we have a number, we can do the number part, the arithmetic, and get out of as much algebra. So do g of 1, then plug that answer into function f. So let's try that and see. We should get 18, same answer. G of 1 means plug 1 into function g. So 2 times 1 squared is 2 plus 3 is 5. So we find that answer to be 5. So then we plug 5 into function f. So over here, that's 5 times 5, 25 minus 7. Again, same answer, 18. Okay, so you guys try it. Do GOF, and let's do 2. Do that the other direction, please. Plug in for f of 2, then plug that answer into function g. So pause the video and try that. F of 2 would plug in 2 for the f value for function f for that x, and that would be 10 minus 7, which is 3. So we take 3 and plug it into function g. In function g, that's 2 times 3 we found from the last step. And that's 2 times 9, 18 plus 3. You should be getting a 21 for that answer. So using the function notation.